In this unit, we're going to see how we can use congruent triangles to prove that corresponding parts of triangles are also congruent. It's known as CP-CTC, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. It's a mouthful. Basically, what you need to do is to prove two triangles are congruent. And from there on, you can draw the conclusion that their corresponding parts are also congruent. Let's take a look at this. In this diagram, AB and CD bisect each other at M. That's a very intelligent way of saying M is the midpoint for AB as well as CD. Bisect, remember, I think it's chapter 2. It means to cut something in two halves, two identical halves. So AM and BM are congruent, CM and DM are congruent. We're asked to prove angle A and angle B are congruent. So before I do that, I have to prove that these two triangles are congruent. So triangle ADM and triangle BCM. If I prove these two are congruent, then we can draw the conclusion their corresponding angles A and B would be congruent. So let's see how we do that. We're given the information that AB and CD bisect each other at M. Therefore, I'm going to jump around a little bit. So from there, I can draw this conclusion that MA and MB are congruent. That's because of definition of segment bisectors. I can also draw this conclusion, right? I'm jumping to point 2, that DM or MD and MC are congruent for the same reason. Definition of segment bisector. And now notice that I have one side, I have a second side. And then I also know that AMD and BMC are congruent because they're vertical angles. That's by vertical angle theorem. All vertical angles are congruent. So now I've got my A. And also it looks like these vertical angles are included by these two congruent sides. Therefore, I have a SAS congruence theorem that ADM and BCM are two identical congruent triangles. Now, if these two triangles are congruent, their corresponding sides and corresponding angles must be congruent. So you can just write CP, CTC. CPCTC. You can write it out like that in exams, and you can draw the conclusion that angle A and angle B are congruent. Okay? Seems like a lot of steps, but really it's still the same deal. You just need to prove two triangles are congruent, and then that leads you directly to your final proof. Let's look at this one. Sketch the overlapping triangles separately. Mark all congruent triangles and sides. Then tell what theorem or postulate you can show triangle JGH and triangle JGH and KHG are congruent. So the first thing we need to do is we need to draw two triangles that are identical. See if I can do that easily. Ooh, close. Very good. Okay, so if I can label this, this will be JGH, and this triangle, see if I can move it whoops, well, never mind. If I label this KHG and make sure you carry the markers correctly, the tick marks, okay? So first step, I sketch the triangle separately, moving JGH to the left and KHG to the right. I couldn't do it on the right, but you got the point. Mark the congruent angles, which is exactly what we did, right? KGH, and then JHG are congruent. Then let's see what we can prove. Let's write out what's given. First of all, we said JHG is congruent to angle KGH. So I've got one angle. And then I've got the second angle, which is GJH, is congruent to GKH, second angle. Also notice that the two triangles, when I overlap them, they share a side. Not an angle anymore. Oops, sorry. So make my eraser a little smaller. It says it's a side length of GH is congruent to GH by reflexive property, right? Therefore, I can draw the conclusion that triangle JGH is congruent, it's congruent to triangle KHG. That's a K. Right? Yep, and I think that's it. We just proved it's asking us to show that these two triangles are congruent, and we did that. Still the same example. This is just to further explain that. So you look for shared sides, shared angles, and any other information you can deduce. Which side is the same in both triangles? We already talked about it. That's GH in the previous slide. And then look at your mark diagram. You can use the theorem to prove that. I think we used AAS. We have two angles and a side to prove that these two are congruent, right? We have AAS. Yep, that's exactly right. The third one, let's see. We have CB and CE are congruent. So CB and CE are congruent here. Okay, notice CB is one leg of this triangle and CE is one leg. That's the corresponding side. And angle DEC is here, and angle ABC are congruent, so that's good. Then we have to prove AB, which is this side, and DE are congruent. Again, if you can, draw these two triangles separately. It looks very much like a right triangle, but if they don't, give you the information that it is a right triangle, you cannot assume that it's a right triangle. So, I am not very good at this drawing piece in geometry, so let's do that. There we go. That's not too bad, right? So if I do A, B, C here, and then this one, so the corresponding sides of AC would be DC, so it would be DCE here. So we said BC is congruent to CE. We said DE, angle E basically, DEC is congruent to ABC, which is this one, right? And notice that they also have a shared angle, which means angle C is congruent to angle C by reflexive property. So without looking at this problem, I know now these two triangles are congruent because I have ASA. So let's see how they do it. Which triangle do you need to prove that are congruent in order to prove that AB, which is this one, I'm going to use a red ink. It's asking us to prove the two red tick marks. So we already said that we have to prove triangle ABC is congruent to triangle DEC. And it's asking us which angle is the same in both angles. And obviously that's angle C. So let's see. What's given is CB is congruent to CE. That's one side, right? It's also, oh, I'm sorry. I didn't label this clearly. So CB is congruent to CE. That's one side. It's also given DEC, angle DEC is congruent to angle ABC. That's an angle, right? So we have one angle, one side. And we also said angle C is congruent to angle C because that's the shared angle and is reflective property of congruence. Therefore, by, we said earlier, ASA, congruence theorem, we can prove these two triangles are congruent, which is what we wrote up here. DEC is congruent to triangle ABC. If two triangles are congruent, their corresponding sides and angles must be congruent. Corresponding sides for AB is DE. So AB is congruent to DE by CP, CTC. Corresponding parts of congruent triangles must be congruent, CP, CTC. Okay, this is really not easy. It's long. So I don't plan to test you guys a lot, but we need to do some practices because this is very important skill to master. When you go into higher level math in the next 2 years in high school, this type of proofs are not that typical. However, this type of logical thinking and reasoning is very important. Okay, guys, see you later.